Hello my dear friends, welcome to this electronic channel. This is Uncle Misha and today we have this. Well, if you remember from my previous video, unboxing of Wyze Bulb White. One of them was 2-pack, turned out to be deadski, like dead. So what are you gonna do today? Well, actually I already mentioned this to the Wyze company and they give me a refund in form of a, how do you call it, gift card. So yeah, I mean, I thought they're just gonna get new light bulb, but refund. Okay, well, that works, thank you Wyze, but better you do good product. I mean, your product is good. I mean, just this is first time something failed from Wyze on me, but nevertheless, you know, quality control please. Alright, so today we're gonna take it apart. I'm gonna try to do as less destruction as possible, but whoa! Hey, I started working out. This working. You see, guys? I just break light bulbs just like that. Ha! Yeah, workout. Nice. Okay. Yeah, we just jumped right into Teardown, like just like that. I'm shocked. Anyways, right, so here we are. So if you're already here, let's just zoom in and start investigating. So this is Wyze bulb close, and as you see, oops, it's kind of crooked here. As you see, we have two different colors, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. We have 12 LEDs of two colors. One is yellow, another is orange. Well, I mean, they are not yellow and orange. This is just the color of the phosphorus right there. So, what kind of information we have? This is model of 2018, so this is clearly an older model of Wyze bulb. And what is this? WC. There is something else. This little snotty thingy here, we're gonna rip it off. It looks like it just soldered. Yeah, this is soldered, no connectors of any kind. Alrighty. It looks like, I thought for a second this is like mains wires, but it's probably not, because you don't have 3 of them. So this potentially is the wires which actually drives those LEDs. Like and they are quite beefy, because probably this is all high voltage. So let's try to attack this thing from other side using my favorite spatulizators. I'm hoping this is gonna go painless without destruction of this thing, because I'm hoping it's done exactly the same way. Technically this thing's supposed to pop. Look, it's identical. I'm not sure what kind of light, forgot what kind of light bulb is. I think this is from Sylvania, which is, as you see, identical. Seriously, it is identical. And main idea here that technically I can just pop this somehow, or this. Well, the end of story. I don't even have to pop this out. I have to remove all that, right? I'll be back. So what I prepared here, I prepared these and a duct tape. So my idea is like that. Hope it's gonna work. Okay, it's barely fits, okay. It's not doing what I thought it would do. Unfortunately. I wanted to kind of yank this instead of destroying it, but looks like it's not cooperating. Let's try again. No. It's going. I think it's going. Alright. It did. Oh, it was. Whoa. Alright, we have a surprise. This, surprise, surprise. Well, this light bulb was broken anyways, so looks like we have a surprise. Surprised that it's all potted. Then, oh, I see. Oh, it's all potted. Oh my god. Okay, now I see it. Sucks. Well, holy smokes. Do I wanna go there? How easy this? Oh, it's actually not too bad. What kind of? It's kind of rubbery stuff. It's not like epoxy. Technically, wow. Technically, it's okay. 1 hour later. So I decided to not go at the moment this way. It was actually to unglue this. It was like super easy. Usually you need to push it from this side, but looks like it's just sitting here. And it's well done construction, by the way. Alright, and it's really hard to show you. It looks like there is an aluminium kind of thingy here, like a base. Like, look at this. Right, and this was sitting on a thermal paste right here. So this is actually well done. It's very well done. Unfortunately, it's very well sealed as well. Can I just yank all this stuff? So out of this dead bulb, the only one what I'm gonna have is like whole bunch of LEDs. It's kind of weird. It's all it's charred. I don't know why it has these black marks. That's weird. So what I wanna just desolder those three. Yeah. So it's yeah, I'm gonna unsolder them. Free that. Sometimes it could be a challenge because this. Let's crank up some temperature here. Yeah, it's gonna sink quite a bit of. Okay, it's this one is off. Let's do controller. This one is off too. Positive something. Sometimes this stupid freaking soldering iron is annoying. Why you stop soldering? Ugh. That's why I need the hardware hack for this guy. It's annoying. Alright. So we are in. Okay, so here is the thermal paste, and here is the LED PCB. Okay, we're gonna put it to this side. Well, rest of the things are mystery because this all submerged. Oh, yeah. Yeah, I think it's pretty much, well, it's, yeah, I have to, if you want to get here, so what I have to do, I have to take my bandsaw and just cut this thing like that, then cut this thing like that, and that's the only way. But I must tell you, this is well done. This, yeah, it's the thermal construction here is very well made, because first of all, this residue, this like gunk here, it's clearly gonna be thermally conductive, right? So it's gonna sink some temperature, gonna irradiate it right here, and this metal can, which is good, like it's probably just a metal can which actually sits there. I don't think I can pull it out. Who knows? Maybe I can pull it out. I don't, but I would, if I would do, yeah, it sits there for good. Okay. Well, you see, I'm strong, yeah? Yeah, working out. So maybe I don't have to cut it, maybe I can just dig it. I probably have to dig on this, maybe it's easier to cut it. Oh, I'm clearly seeing expressive, so clearly this is a candidate for ESP, probably 32. No, maybe not, 2018, no, it's not ESP 32, no, I don't think so. Guys, should I cut it? Or not? Should I cut it or not? I never actually cut the. This looks like aluminium. Yeah, it's gonna be a piece of cake. Gonna just remove this. Clearly, I'm gonna just yank it. Well, I didn't yank in the way I wanted to, but whatever. It was somewhere here. Yeah. So, well, yeah, be back. Here we are! Ta-da! Well, this side turned out to be better than this side, but let's see. Ooh. Okay, so I cut completely all the way to the whatever gunk, right? Yeah, so. Okay. Okay, that's good, that's good. It's good. Technically, you can do this on this side too, I guess. Yeah. This remove the shell. We can also analyze the composition of this as well. Nice. Okay, so what do we have? We have aluminium can, which is probably 0.8 or about 1 millimeter thick, and then we have plastic shell, obviously for insulation. So yeah, this is what we have. Now it's gonna be fun. Not sure what kind of pokey poker I have to use for that. Should I use something like this? Oh, actually cuts pretty well. Pretty cool. It has some air pockets. Actually, air pockets, as you see, is not best for thermal conductivity. Air bubbles, air pockets. Yeah, so not sure about that. Oops, I think I'm cutting something. Yeah, okay. Cutting probably. What can I try to do this or something? More like it. Yeah. Oh, transformer. I see. Capacitors. What else are we gonna reveal here? You know, guys, there is like this children archaeologist kind of game. I think this is what reminds me. This thing oh shit! I think it damaged this cap. Oh, there. It still doesn't. More capacitors, huh? I thought actually this side would have less stuff. It looks like it has more stuff. Ow! Shit. To make sure I don't gonna cut my stuff. It's good. It's blunt here. I'll be lots of blood right here. Okay, we're getting closer. Whoops. Oh, neat. Oh, look at that. This is awesome. Oh, beautiful. Nice. Okay, we're having fun here. Looks like. Are we? If you wanna power this thing up, maybe, because it's I don't know if I didn't damage anything. I have to be very careful not to rip off any components. But looks like it's doing well so far. I'm not sure if we're gonna power it up. I don't wanna really go in here and analyze the fault. That's rather a lot of components. Is this resistor not looking good? No, looks like it's okay. Alright, let's continue. Well, other side will be much harder to deal with because it's, yeah, well, you know what I mean, like, right? Fusible resistor here, I guess. Yeah, I can use my nails, just like, hope I didn't cut capacitor here, that'll be hilarious. Oops. Wow, it was so close to the capacitor. Maybe it's actually damaged. Let me see closer. No way, I didn't kill it. Ha, I didn't. Wow, okay, well, it's good to know. Yeah, that's tough. What kind of capacitor is this? I don't know. Well, I'm not gonna see, I don't think I'm gonna see any kind of Rubicons or Nichicons or anything like that. I hope it's gonna have decent caps. Okay, transformer. It's fun, guys. I think it is for a little tiny inductor right here. I'm curious what for. Well, yeah, I think I know what for, because you have to have you have to have a power supply for the LEDs, but also need power supply for this. I'm just curious how it's done. Is it like another just switch? Oh, another inductor. It's our output inductor. Is it like just switch? Sorry, not switch. I'm saying. So excited, start forgetting my words. A linear regulator for that, you know, or special something. Okay, there is a rectifier diode on secondary. Yeah, it would be really hard to get through here. It's probably the most complicated part. But maybe I don't have to, because it's just gonna be a transformer and that's pretty much it. Yeah. Actually, here. LDO. Is it? T. It's really hard to say. One. No. I need like magnifying glass. Where's my little tiny magnifying glass? MT7201. Oh, I don't know what the heck is this. Look like this guy looks like LDO, but it's, I don't know what kind of driver chip is. KP3211SG. Nice. So we took it apart pretty much. Maybe I'll poke around here a little bit. Yeah, I don't think there is more. Just need to rip it off small components because that's easy to do. So this little inductor here, because we have, I don't know what's this for, because we have this inductor. Has capacitors. Okay, what kind of is? Okay, this is ESP room 02D. So yeah, this is like a nice module actually. Nice. Okay, I think I'm gonna stop. It's kind of tempting to gonna keep digging, but it's getting into territories that can start ripping the components off, right? Yeah, well, I don't think there is more. Look at this, another air pocket right here. All right, so we have our stuff. So first of all, let me stop here, okay, and take a shot of all this mess. I'm gonna take a picture here. I'm gonna take a picture. Okay, let's just put this in the middle. Yeah, I'm gonna take a picture of all this mess. So what Uncle Misha did today. Beautiful Wyze bulb. So now when our photos are taken, I can just clean all this mess up, because that's just can't go away in the garbage. Maybe I'll leave this one and this one, I don't know what for, but just leave for now. This is definitely going into the garbage. Curious, this is center or this is side? Oh, there. Okay, let me clean this all up. Okay, let's do some poking around while we are here. So first of all, let's see what's going on the input side. So this is our bridge rectifier. Okay, so let's, it's really hard. I need to hold it like this. Oh, okay, so we have, okay, so it's clearly, okay, so bridge rectifier would be powered. I assume they're not. So this trace goes through this. This is the resistor, and this trace. Yeah. So this is resistor, and it goes back here. So the bridge rectifier is gonna be powered. So let's check bridge rectifier. So let's check our bridge rectifier, and let's see here. Nothing. Swap. Alive. Nothing. Yeah, bridge rectifier looks like is okay. What can be another problem? Yeah, I honestly don't know. Like, why do we have another rectifier here? It's kind of interesting. This does look like a rectifier arrangement, but why do we need second one? Hey, I've done some reverse engineering. I obviously didn't draw the schematic, but still it was a lot of things to figure out, especially to Google or search for all necessary or components here. So what do we have? There are a few puzzles here. So number one, so we have bridge rectifier right here, which then we have this, first we have this filtering part thing, which CLC filter, like this capacitor, this inductor, and this capacitor. Then it's all goes to this bridge rectifier, and then it goes to those two capacitors. But then there is a puzzle. Why do we have another bridge rectifier here, which I could not wrap my mind why do we have, because it looks like it just it's induct. Actually, these inductors, they are after this bridge rectifier, so what the heck? Yeah, LC, why this is after bridge rectifier? I thought this has to be before. Okay, then obviously there is a bridge rectifier, our C, another capacitor, and inductor. Right, then there is another bridge rectifier. This is kind of weird. I'm not a specialist in switch mode power supplies, become weird. Anyways, let's go further. So then we have this driver, and this driver is a monolithic device which actually has everything and doesn't even need transformer because it's floating. So essentially this device not supposed to be poked with people, right? So this doesn't have to have insulation transformer between primary and secondary. So this guy high performance switch mode switcher. So this switcher has MOSFET in it, it drives everything, and yada yada yada. This guy is not a transformer. This guy is inductor, which works together with this gentleman. So because I thought this is transformer, because this looks like a transformer, it actually says T1, but this gentleman has only 2 pins. Like, yeah, I mean, it cannot be transformer, right? These other pins are all accounted for. So this is 2 pins only. So this guy is a inductor. So output of this guy is actually 12 volt. This is what I derived from the Chinese documentation, because I find only PDF for this guy in Chinese. So from I understood, 12 volt. Wow. Anyways, high voltage DC, 12 volts output. Then we have this guy. Looks like it's connected to this guy, and this guy is not what I thought what it is. I thought this is 3.3 volt regulator. No, this guy is LED driver with input voltage from 7 to 40 volt input and 1 amp output. It can drive a bunch of LED up to 32 watts. So that's actually pretty decent gentleman right here. So this guy, and it's if you trace, yes, it's connected to LEDs. Because how do I know that? Because there are 2 transistors here, which I thought is MOSFETs, but no, they are actually NPN transistors. These are driven by this microcontroller, and these are driving 2 separate strands of LEDs. So this LED and this LED, and this one is always it's not like it's the positive, and those 2 are connected to different LEDs. Those 2 transistors are connected to this gentleman, so to the LED driver, and another pin is connected to microcontroller. So those 2 transistors. What is this little guy? I do not know. I could notice little few, like 2 letters only, and really hard to tell what exactly is this. It says it's a transistor, but why do you need another transistor? Because there is, I don't see any LEDs here, like, I mean, indicator LEDs, so I don't know why there is another transistor right here. And if we go, there are some pins right here, and looks like it's connected to one of those pins, so we have to, you know, think about it. Maybe I am wrong. Okay, let's go further. This guy turned out to be this Givanj. I thought it is, you know, actually should be somewhere 3.3 voltage a regulator, and it is JW5018B SOT 23-6 regulator. Buck regulator. Actually pretty interesting, gentlemen, as well. It can take up to 40 volt in, so yeah, it looks like this guy is going pair. So and in this case, it's clearly, if you look at the so trace this pin, this is like a 3.3 volt pin right here, and it is it yes, it is. It is connected to this pin, or connected to this capacitor to this regulator. There is a Zener here. This regulator is connected to all these jaws using this Zener and to output of this Zen. I don't know why do you need Zener here? I don't know, but it is. There is another little inductor right here. There is another inductor right here. Again, maybe there is something underneath here, because there is another tiny inductor right here. So there is a whole bunch of inductors, and really hard to tell where it goes, because a little bit of gunk still left on this board. I think that's pretty much it on this side. So let's talk about espressive. So this espressive, as I was right, is ESP8266EX. Wi-Fi, not VIF, Wi-Fi. 50 kilobyte of RAM plus SPI flash. Nothing to write home about, but at least it is all familiar 8266. And it cost about $4.50, $4.65, up to $5 per piece. Yep, and as you see, obviously there is a whole bunch of headers right here, so clearly this device can be reprogrammed. That's pretty much it. So I did not risk it and connected this thing. I'm not sure if I need to. If I have, like, I don't, there is no point for me to actually make it work, because what I can I destroyed the whole housing, and this is not safe to use as is, right? So what I can do is actually unsolder this guy and just play with it, or another option would be just externally power it from here, connect it to serial, and just, you know, poke around and see what can I do. I have a lot of different microcontrollers, so I don't have to reuse this one. There are some interesting components here though, like especially this LED driver. And if you know, what would be the case if you have 2 bridge rectifiers here, because I don't know what else this can be also served, and it clearly looks like it is in a bridge rectifier configuration, because these 2 connected together diodes and these 2 connected together, right? So they're clearly in a bridge configuration. Why do you have to have 2 bridge rectifiers? Especially one after another. It's, yeah, you're good, your guess is good as mine. Yeah, and also there are 2 capacitors. Oh, by the way, this capacitor is really cool. It's branded X-Boom. X-Boom. Have you ever seen X-Boom capacitors? Yeah, well, here we are. Those are high voltage capacitors, right? They are actually in between those bridge rectifiers. 400 volt, all capacitors rated 105C. This one is interesting. It's 50 volt capacitors, this guy. So yeah, still need to understand why the heck we need 50 volt capacitors right here. Capacitor. Yeah, I'd like to know what this Zener is. Maybe this Zener will give me an answer to what the heck is going on here. Right, what else is interesting? There's a whole bunch of weird capacitors. This brand is Wyme. Yeah, this brand is, there's 2 Wyme's and 2 Axe Booms. Very nice capacitors, very colorful. All of them 105C rated. I guess that's gonna be pretty much it. I'm not gonna do any hackery with this guy. I'm not gonna do any you know, repairs. This is just, maybe if in my other light, no, if other one dies, unless this is just LEDs, I can't do anything. I cannot take it, like I cannot take it apart, because I won't be able to put it back in original shape. Impossible, maybe, yeah, impossible. So guys, that's gonna be pretty much it. If you were interested to see what's in your Wyze white bulb, or Wyze Bulb White, here we are. This is what it has inside. Thank you for watching. See you next time. Stay tuned for new videos. Take care and ciao.